It's like a mind map.
It's recording.
Could you not just understand it through a mind map so that's a video? You should take
No, so you need to be able to kind of listen as you go through these. Right, is it recording?
Yeah, it's
Okay, so
recording.
get rid of that. Okay, so we're going through optics. Some of the main things at this stage you should know, as well as being able to do the maths, rearrange the things, you should remember that there's certain steps that you have to learn off you take depending on the question you're given. So the first thing I want to kind of look at is we know that there's 3 different formulas for 1 over f. So we've got this version. Abby, give me another version.
1 over u minus 1 over v minus 1 over f.
Okay. And what's the last version, Matthew?
1 over v equals 1 over u minus 1 over v.
Okay. In terms of lenses, I use these 2 formulas when I'm talking about a convex lens. In terms of mirrors, I use these 2 formulas when I'm talking about a concave mirror. Why would I use 2 different versions? When do I use this version? When the image is what? Real. And I use this version when the image then is virtual. Okay, and then I use this version whenever I have a concave lens or a convex mirror. The reason there's only 1 version being that there's only ever a virtual image formed. Okay, so next thing to kind of say, if I'm doing a maths question involving these, let's say I was told that f is equal to 10 centimeters and the image is twice as big as the object. Find u. So I'm using my formula 1 over f is equal to 1 over u plus 1 over v. The issue is I have too many unknowns. I only know 10. What other formula do I immediately think that I'm going to have to use if there's too many unknowns when using this formula?
M equals e to v over u.
Okay, so you do m is equal to v over u, writing it down before you sub in your numbers. So 2 is equal to v over u, 2u is equal to v, and then you start subbing in. 1 over 10 is equal to 1 over u plus 1 over 2u. This is now algebra then, so 1 over 10 is equal to, we're going to double that so that we can add them together. 1 over 10 is equal to 3 over 2u, cross multiply, 2u is equal to 30, u is equal to 15. Okay, so whenever there's too many unknowns, we know that we need to do this algebra trick using the magnification. Okay, other things to mention whenever using these formulas. Don't forget that if you find 1 over f is equal to, I don't know, 0.6, you have not found f, you found 1 over f, so you need to flip it. F would then be equal to 1 over 0.6. Don't forget this step, it's one of the most common steps that people forget to do. You are not asked to find 1 over the thing, you're asked to find the thing. So it needs to be flipped. Okay? In the 2 mandatory experiments that come up in which use this, they use so the mandatory experiments will use the plus version. 1 over f is equal to 1 over u plus 1 over v. That's the version I'll be using for both the concave mirror and the convex lens. Okay, so 2 different experiments. Your sources of error are the same for both of them. So the sharpest image, it's hard to locate that. Error of parallax when measuring the object distance or the image distance. And then finally, you might have that your mirror or your lens, depending on the experiment, is not vertical. Okay. Okay, so there's some kind of sources of error that work for both of them. You should know how to find the approximate focal length. It's what you do before the experiment starts. So again, the approximate focal length is the story. I'm not going to write the whole thing up here. But it's to do with shining light from a distant object onto a page using either your lens or your mirror, depending on the experiment you're talking about. Finding the sharpest image and measuring the distance from that lens or mirror to the screen. That's your approximate focal length. Again, we find the approximate focal length because below that you get a virtual image which couldn't be located on the screen for the experiment. Okay, things to remember with ray diagrams, guys. Always label your object, label your image. Draw in the arrow for the image. What I mean by that is it's very common that people do all their ray diagrams correctly. So let me put in some focal points here. So straight and through the focal point, and straight, and they stop there. This came from the top of the arrow, so this is the top of the arrow. So you put that in, then you label object, you label image. Okay, so please make sure that your object and your image are labelled, that you've drawn in your arrow where the light rays actually intersected or appeared to intersect, and that you've drawn in the correct shaped lens or mirror. Also be careful, people often, they're asked to draw a mirror diagram, they draw a lens. They're asked to draw a lens, they draw a mirror. Be careful what they ask you in the question. Okay, other things we need to know. If you've got a question, like the one that we looked at the other day, where it's going from. I'm going to make that a bit more obvious, so more refraction there. Okay, so it's going from glass into air. Remember then, first of all, think about what the angle of incidence is. It's between the normal, the imaginary line, and the incidence ray. And the angle of refraction is between the normal, the imaginary line, and the refracted ray. But remember, if it's going from glass into air, or from a denser into a rarer, glass into air is equal to 1 over air into glass. So in this case, sine I over sine or, when going from glass into air would be equal to 1 over, let's say I was told that the refractive index of this was 1.5. It would be 1 over 1.5. Yeah? So that's a trick. If it's going the wrong direction, don't forget this. This is not in a log tables. The other thing that's not in a log tables, guys, that you must remember is real depth over apparent depth is equal to refractive index, not your log tables. Right, and then last one. If you were told that you have some light or something at the bottom of a swimming pool, and you're asked to find the radius of the circle of light that's made above, or the area of the circle of light that's made above, you should have learnt off at this stage how to do that. So just remembering, light is going out, so this is my incident ray, this is my refracted ray. So between the incident ray and the normal, this is the critical angle whose corresponding angle of refraction is at 90 degrees. And by maths, that would also be the critical angle then. So you should just know before you even start that question that that's the critical angle. We then use refractive index equal to 1 over sine c, find c. And then we're going to use tan is equal to, so the alternate calculator till old age, so opposite over adjacent. So in this case, tan of c is equal to the radius over the depth of the pool. So you can then find the radius. And then the last thing you might be asked to do is to find the area, which is equal to, it's the area of a circle that it will be making up above. So it's pi r squared, your radius squared. That can only be known, even if you can do the math solidly, you need to know yourself, you have to learn off how to do that question. You should see it, oh sweet, I know how to do that one. Okay? So, the rest, just be familiar with finding all this stuff in your log tables. Again, these two versions here, they're not in your log tables, that's not in your log tables, that's not in your log tables. But the ones that are in your log tables are that one, you've got n is equal to c1 over c2, you should know what that means. It's speed in the first medium, speed in the second medium. N is equal to sine I over sine r. Again, you can find that, and this one. So I think that is all the equations that we've covered, and most of your information summarised very quickly on the board there. Okay? Also, obviously, make sure you know your definitions: critical angle, total internal reflection, real image, apparent image, reflection, refraction, and so on. Alright?